range. So we have to figure out a way to deal with that. So split val to range takes two parameters: the string val to split, and then the type to convert it to. It's probably a better way to do this, but this is how I'm doing it now. So up until you get to the after the split val, it's the same as the other ones, obviously. Then this is where it gets kind of crazy, because I don't have to call this create binfo thing every time we have one of these. And I don't want to create a function just to call this one line of code, because then you're creating, you have to use it 1, 2, 3 times, and you're basically creating 1, 2, 3. Well, you're creating one function in the header. You're creating one for each call, so that's 4. And then you're creating another line to actually execute the code. So that's like 6 lines of code, where you could just use it once, or have 3 lines of code and use it once up here. So it's actually more economical to do this way, if not as pretty. And then so what this is checking for is to make sure that you didn't pass through a value, or the game didn't try to pass through a value that the player or the modder set that was smaller or larger than 2 values, because we're working with a range here. It should only be 2 values in a range. So if it's 1, or if it's more than 2, it throws an error, and it should return a actually it should return a range. It should return this range. And this should be an else if, actually. Little bug, not really bug, but unwanted behavior fixing there. Alright, so if you don't have the right number of elements, then it'll throw this error to the error log, and then just give you back a basically a default oh no, yeah, well, yeah, okay, yeah. We didn't need to do that. I didn't remember what I was doing down here. So the reason why I thought I could do this every time and didn't want to is because we're also checking the same thing here to see if you only have 2 values here. Because if you have more than 2 or less than 2, we want to return just a default range for the type that you want. So in this case, it's going to return a range, but it won't be it'll use the members of the range that are expected to be used, so that you won't crash the code with null values. Sure, it won't actually have the correct values for calculations and things, but you're not going to crash because there's a null value there, an uninitialized value that's like a negative 32,000 whatever something value. So this was the best way I could think of to do it for ranges, and doing it this way made things way the hell easier. In fact, I was able to basically remove half of the settings. No joke, half of the settings implementation file is now gone, because I was able to clean up the code so much. Remember all those double calls to those functions that had like the is bool max whatever things? Those are gone now. All we have now is we just have these functions which take a range, and you set the range to whatever the range variable is. And when you set it, when you're going to call that to set it, this mouse, all you have to do is call split val into range. And then you pass, since it returns a range, a range, you just pass the return of that into the function, and you're done. So this class is now namespace is much shorter. It is 525. Actually, let's go take a look at the number of lines. Because we can look at it. So I uploaded that commit last night, or not last night, but a couple nights ago. Or it might have been last night. So, settings. So yeah, 254 deletions and 165 additions. The additions are for the moon stuff, so I did those at the same time. But yeah, 254 lines removed out of 500, 600-ish line namespace. So these are all this is all the stuff that got removed. Oh, also, actually, this isn't the one. This is the header file, right? Yes. And the header file, I found something interesting, which is really strange. The header file for namespaces do not define the tips, I guess you call them, for the variables. It's the implementation of the namespace that does it. So I can clean up the header by taking all this stuff out and only having it in the implementation. But I'll show you what I mean later with that. We want the actual, that's the header. We don't want the header. We want the, where are you? Damn you. Oh, here we go, this one. Yeah, is that the right one? Oh, no, it was the right one. We're looking at the wrong diff. That's what it was. So, as you can see now, we have all this here. These here, this here was folded down into this. So, literally, we just cut it in half. So, instead of having, like, looks like 11. No, it can't be 11. Maybe, no, it's 11, yeah. 11, we have 6, I guess. 1, 2, 3, 4, 5, 6, 7. One of them is not a range, I guess. Or is one a range? Okay, 2 of them were not ranges. That's what it was. Planet, def, rand, range. Oh, no, they were, well, interesting. No, this got changed to this too. Weird, I'm not sure what the hell happened with that one. There's supposed to be like this kind of thing on it or something, I guess, but it wasn't. Oh, def range. Oh, okay. These were the single value ranges. I've changed any single value ranges into dual. So instead of having this be just hard coded as a 1 or a 0 or something for the first one, it's now a value from the database. That's why I was like, what the hell's where'd these go? That's where they went to, and trying to figure out what they were. Yeah, so all that stuff got cut down by half. All of this is gone now, down to this. So we don't have this crazy-ass crap here anymore. It's all nice and single-lined. So actually, it's more than even half for that. All this went down to 4 lines. It's very, very, very clean looking now. All of this is gone. It's all single-lined up. Let's see if I can find the bottom of this so you can figure out where the... So yeah, the last line was 615. We're now at 526. So take out the 100 and... how many lines of code was it we added? $165, so that's like So that's about, we took out about 400 and something lines of code. 411 lines of code, I think. Or, yeah. If I'm reading that correctly, 411. 311. 1. Oh, that's it backwards. So 15.9. No, because it's 15 seconds down to 14. That's 14. So 9, 8. So 289 lines of code we took out. 189 lines of code. I don't know. We took out a bunch of lines of code. It's too late for proper math this late at night. But so we did that. Which really got this looking a lot cleaner than it was. A lot smaller. Be much easier to maintain and add things into it now. Because it was getting pretty frigging gnarly getting through all that stuff and trying to figure out where stuff is at. What else did I change, work on? And I guess that's really it. It's all I really managed to get done. One thing I still have to do, I still have to add in the huge asteroid size stuff for asteroid creation. Still haven't done that yet. I'll get to that eventually. Right now, I'm working on moons right now. What I was working on just before I started this was moving the security rating level to the object class, because lots of things are going to need to use it now. It's not just not use it directly, so to speak. Only thing using it directly will be the system, but planets need to have it for calculation. Asteroid belts need to have it for calculation. Stations will need it for calculations, and moons will need it for calculations. Since these four need that value, need to store the value, either temporarily or permanently. In this case, I'd rather do it permanently, because that value will change over time, and as it changes, so too should the stuff that are generated by those values. So, a new system that you find may have some really nice ore and really nice stuff at the stations at the beginning, but as it starts to get up and higher in the security levels, that stuff will start to filter out, and you get the more middle level to mundane kind of stuff. And in order to do that, we'll need to have the that value there to be able to modify so that we can update it over time. Which is a reason I just thought of right now that I didn't think of before. So that's why I'm doing that, and that's what was starting to work on. And this is also a good example of how I work as far as programming. I'll create something crazy and really kind of complicated looking and overbuilt and whatnot. Then maybe 2 or 3 months down the road, I'll look at it and say, oh, I could do this instead, and all that stuff is gone, and it's like one line of code now or something. That's pretty typical for how I work on stuff. That's pretty complex that I don't have to have any kind of real deadline to finish. But that's all I wanted to show. So that's going to be it for this kind of mini recording session for the developer vlog. The next time we'll do some will be the main one for mid-November or so, where I'll have hopefully the moon stuff done, the asteroid belt stuff done, and maybe hopefully all the moon stuff done, not just the deposit generation, which is what I'm working on right now, with all this stuff, but also the calculations and things for setting up colonies and stuff like that. And maybe, hopefully, I've gotten a little bit further than just doing the store menus for stations. Setting those up and figuring out what would be in those inventories for whatever conditions we wanted, and move more into starting to implement some of the game stuff that'll actually make this run like a game instead of just a tech demo, if you will. We'll see what happens. Hopefully I get that far. I will try and have some stuff from UE4. Probably going to be a very early version of the UI, hopefully. At least one of the UIs. And maybe also some audio stuff. Maybe not. And I may have some more of the tool done to show you as well. So, I will see you then. And if you haven't done so already, we'd appreciate it if you'd subscribe to the channel. And I will see you then. Hi everyone, this is George Williams from Lifetime Productions Squared, and we're back to do just a very short, probably 5-10 minutes or something, video here for Developers Vlog 20. Another instance where I just have completed something and I wanted to kind of show it off, and because it's a leap forward in progress, let's put it that way. Because it allows me now to more quickly establish the same functionality for other things to complete, in this case the mod tool. So what we're going to be showing you today is the newest code that I have now that has put in to enable creation of records and saving of records. For right now it's just working for armor plating. I have to build out the code to do it for the rest of the tables, but for armor plating it's working. At least as far as and there are some places where there's problems because I'm not checking the content of the fields that's being entered, so there'd be there are errors that'll happen from that if you're trying to put like a string into an integer field, but that can be dealt with later. Right now the focus was to actually get it working, period, and I seem to have achieved that. So first let's just go ahead and show it to you here. Let's go to the splash screen. Alright, so here we have our main screen here. We'll load the database, go to the database editors. First we'll go to editing mode and then armor plate. So as you can see, there's nothing here, which is expected. Let's shift it over to record creation, and again we'll have to do this to update the fields. So for when you're creating records, you don't have to. You can just ignore the ID field. I'd suggest to leave a value in there, just to leave the 0 there, but the rest of it you can change. So in this case, we're going to create a basic armor plating thing. So let's call it. That's another thing. If you try to tab through these, you'll never hit the description box because of how it's not in the tabbing order or something. So it's kind of annoying. The rest of them work that way, but just the description box you won't be able to reach it at all. Actually, description for this this basic armor plating fits onto most frigates. This basic simple thing. Class will be frigate. It's going to be the ship class Tikla. Let's see, 1 power requirement 0 because we're not actually repairing anything. CP required none durability. So the amount of armor points that we get from this, we'll say 75. Power consumption none, repair rate none, repair delay none, because this isn't a self-regenerating thing. Weight, we'll say 85. Cost, 1600. Let's see, ruby cost, nothing. Well, we'll give it a little bit of a ruby cost. No diamond cost. Draconic cost, 3000. No lithium, uranium, plutonium, or nuclear waste costs. So now we have this data in. We hit save data, and it will show up down here. Boom. Now, of course, this is because I was testing it earlier, so this ID would normally be 1. Now, if we go over to the database editor, or whatever you're using for that, in my case, I'm using SQLite Expert. As you can see now, it is over here in the database file. So now let's say that let's say I messed something up and I want to change something on that. Let's say that the draconic cost is too high. So I just switch over to record editing, then I just reload it, select the table to reload it, and then I can just change this down to, let's say, 1400. Save data. Now you see again, it's been successfully updated. If I go back to the database again, you will now see that the draconic cost is 1400. So it is working like it should be, and so far the only issues I've found with it is that if you put something in a box that's not supposed to be there, so like if I put an A here, it would throw an error because an exception unhandled string. Because what I'm doing is, and we'll get into the code now. So how this is working is, I'm using, I swear this is like freaking voodoo code or something. I have no clue. Not voodoo as in magic, but voodoo as in the type of code you'd never want to frigging ever use. But I've kind of pieced together this craziness to make it work. So let's talk about how it actually works. First and foremost, let's look at here. We have one object here, A plating, so that's why it's the only thing that's working right now. It's the only one that we have defined here. So A plating, which is A plate, APLT. We go through here, we initialize all the structures in D object. So D object's the main intermediary class between the main form and the structs class. So the struct class defines everything. And this is going to be annoying because what I have to do is I have to go back through and do all the fields in order so that when we are loading them in the way I'm loading them in, because doing it this way is easier in terms of less coding, they have to be in the order that you're expecting them to have to be, in the order that the database is expecting them to be in. So like this, like I have here, this wouldn't work because this would be first, second, third, fourth, fifth, sixth, and it's not supposed to be in that order because the database has it in a different order. So I have to go back through, unpackage this awesome compact version of it that I made for the game, and put it back into this lengthy, long BS version because that's the way it has to work with the way I have it coded right now. And the way I think it's just going to have to stay that way because I don't think I can figure out a way to do it with less code and not have to do it this way. Anyway, so this is the intermediary class between that. And so what we're doing is we're calling, and this is so ridiculous, but we're having to do this. But we have to do this. So what we'll do is we call this init structs, which will initialize the data object instance of the struct. So in this case, DAPLT. So data A plate, which is corresponding to a reference or instance down here of that. So we initialize all the structs, and every struct instance will have this stuff up here, and will have their own set function, so that we can set the values. Now, to be honest, I'm not sure if I'm actually using this or not. I may not have to use this, which would be awesome because, yeah, no, I don't have to use this because we're doing this in the, we're doing this somewhere else, so I don't think I need to use this, which is nice. It's not, in terms of like the design of it, this would be better because, we're messing around with this object, and this object is defined here, so you'd want to, design-wise, you'd want to mess around with this stuff here. So you want to pass through all the values that you get from the application into here to cast to the proper types to save them into the object, then return the object to use it. But I'm not doing that. I'm just doing it all over in the main thing. So maybe we'll get back to this eventually. But for now, the way that's working is the way it's going to work. And this would be more like doing this, switching over to this would be more of a kind of a polishing up thing that I do towards the end of the development of the tool. But anyway, so we initialize the well, first we initialize the d-object instances of the structs, and then we call the d-object instance of the struct and set it to the instance here in this class. So we're kind of doing a monkey in the middle thing with the data object class. And I think that's the last time we ever use the data object class for anything, really. So we do that, and then the application loads. So then you do the normal stuff that we go through, switching the, loading the database and switching over to the editor, changing the work mode, and then selecting the table. Now, once you get to that and enter in the stuff, this is where the interesting stuff happens. Enter in the data, you hit the save button. So the save button is defined down here somewhere. Here we go. Save button DBE click. So if we're in create mode, we're going to call this select object to update. So this is an internal thing where it's looking for the table you have selected. It's passing then the struct instance from this class to update object. We're passing this as false because I have to add this in because of a stupid issue, which is that when you're updating a record, you have to have the ID of the record to update. It's stupidly obvious that you need that, but I had forgotten to do that. And so what was happening was that I was trying to update a record using the ID as 0 because the ID is set to 0 when when you're creating it, or when you're creating it, because the value that's loading is the default initialization value from the dObject class. So if you remember when we were initializing the dObject class, the values that are stored in that dObject instance of the struct, those values are the values that are loaded into the database editor when you are creating a record. Those are the default values. So now I get those connected together now. And so that will always be 0. So if we're not updating the ID field, ID field, I guess, ID field of a APLT, it's always going to be 0. Thus, it'll try to update on record ID equals 0 when there is no such record, so it fails to update silently, and it doesn't crash the. Doesn't cause an exception, but it doesn't update either because the record doesn't exist. Anyway, so we're passing that through here to here into this class. So now we have the class that we want to update, and this is why we're using object, and this is why I say that I didn't. The choice to do this made me want to like freaking stab myself or something because I hate ambiguous crap like this. You could never do this in C++, and I am glad. Or at least I don't think you can. If you can, then damn it. If you can't, then I love it for that reason. But you can do this thing where you have an object, and an object in C# can be ambiguous. It can mean anything. It can be a string, it can be a list, it can be a custom object, like a struct, like I'm using in here. It can be, I don't know, Santa Claus. Who knows? It can be anything. As long as it's an object, and everything in C# is an object, pretty much, so it can pretty much be anything. So this is like the nuclear option to solve getting rid of an anthill. Dropping a nuclear bomb in an anthill to get rid of it. Does the job, but you also then blow up half of the city to do it as well, and then turn the whole area into a nuclear radioactive wasteland. That's how I view this object thing, but at the same time, it works, and it makes this so much easier because if I had to do this individually as a type, specific type, I'd have to have this update object multiple times for every struct that we have. Since we can do it ambiguously, I just pass in this object called obj to update, and everything is golden. So we're passing through an object called obj to update, object to update, and this b is update. In this case, we're going to assume it's false, so we're creating a record. Object to you get list. Is that right? Does not seem right. Yeah. Might be working for surprisingly strange reasons. So what class is that? Get list object. So get list object. Get value. Okay, no, that's fine now. I thought it was something else. So we have this utility class that I have set up, and we have a couple of different functions in there. One of them is to get a list of fields from an object. So it's kind of like getting them from a database, except you're using reflection in C# to get the field names of the struct. So we have this object that we have here, and we're going to pass it through to this class, this function of the utils class. This function will also return a value list if this is true. So if you want to get the values of the supplied object, then you can use this as true. I'm using it as false because we want to get the field list. We're going to get the values from the form, so we don't need them from the object themselves. But when we're loading up the default values, we are calling this as a true parameter here to get the default values from the object to put onto the database editor when we're creating a record. So load the default values. So we're doing that. This is getting called. So we have an object which is that object update is becoming a structure object. Still an object though. We're creating a temp list of string, and then we are using the system reflection field info. So this is important. If you're using a struct to do this, you have to use field info because structs do not have properties. If you try to do it with properties, you'll get basically nulls back all day because you don't have properties in a struct. So we're calling for field info, so we're getting all the fields basically. So then we call the get field list, which is a thing down here somewhere, passing through the struct object. And then this is where it kind of gets nasty, like it would have to be for other places if we were doing it this way. There may be an easier way to do this, but this is why I'm doing it now. Because we have to specify the type of as being a concrete object. It cannot be a instance of an object or a variable. It has to be a concrete object. So we're looking at the structure object and saying if the structure object is a plating, then we're going to get the a plating fields. If it's cap, then we're going to get the cap fields. If it's clone, we're going to get the clone fields, and etc., etc. So this is similar to what we would have to do the other way if we were doing it in a non-ambiguous way like I would like to do it, but it would make so much more code. So basically what this is just doing is it's checking what the structure object passed is, the type of it, and then if it matches one of these types, it says, okay, type of a plating get fields.toList. So we're getting the field info information, and then we are casting it to a list to return it to temp list, and then return temp list down here at the very bottom. So then get get fields is a standard thing. It's not something I created. So then that we get it back sent to here. We have the field list. Now if bGetVals is true, so we passed through a true before, then we call getVals, we pass through the field list, and then we pass through the struct object. And this comes down here, and we say we're passing through a list, system reflection, field info, field list, object, structure object, creating a temp string list, and then we're saying for each field in field list, temp list.add field.getValue structure object.toString. So we're saying that for every field, we're getting the value of that field using field.getValue structure .toString. We again have to have this here to identify the object that we want to get the field from, and then toString. Even though, well, toString because not everything is a string here, and everything we want to load into the app is a string, into the form is a string. So we want to change it to a string here, and then return the temp list again, and then that gets returned, or we just return the field list if that's all we want. But I still call this one, and we return it as a string list, because right now what we have here as field list right now is just a list of system reflection field info. To use this to say set the label names, the label text, we have to turn them into strings, and that's what this one does here. Just goes through and turns it to a string and adds it to the to a temp list and returns it. So yeah, for var field and field list for each field, well, for each str list equals field to string dot split. You have to do that. So you could do this easier by just saying dot name. Like an idiot, I figured dot name didn't exist because when I tried it with a lowercase n, it said it didn't exist. But it's an uppercase n. Everything is very case sensitive. But you can do it this way too. It's a little bit longer, but you can do it. In this case, we're saying field.toString.split. Now we're using a split because when you just return the field like this, what you're going to get is the field type space the field name. So whatever the system.whatever for string is, space name. And so we split it on the space, and then we take the second object, second element of the str list vector array, I guess, or list, which will be the name for the field. Pretty complicated. So once we do that, though, then we get vals from app, which is this one. So we get a temp list going of string. For int, we set i2 to int i2 to 0. Then we're going through an iterative loop using i1, setting it to 0 as long as i1 is less than text box list.count. Then we're iterating i1, i2 by 1 each time. And we're checking now if the text box list i1 is enabled. So this is important because we only want the values from a text box if it's enabled. If it's not enabled, that means that the table we're working on does not have that many fields. If this wasn't here, we get an index over out of bounds error. Actually, I put it there just for that reason because I was getting an index out of bounds error. The That's just to prevent us from pulling all 30 whatever fields if we don't need to use them. Then the next one, if I2, and this has to be done on a per table basis because we have to do special handling for certain things, like for settings. The description field is the third field. So, that's what this is supposed to be about handling. I haven't tried this code yet with that because I haven't actually had haven't actually tried it yet, so I don't know if it works properly or not, or what else has to be added here. But something probably has to be added eventually. And then if it's not, if I2 is not, if I is not 2, and if I is 2, but it's not settings and the script box dust box is enabled, then we want to get that. If this evaluates to false, then we want to do something else because we have to handle that issue with the description being the third element instead of the second element in the list, which is very annoying. Well, it's actually not an element in the list, but it effectively becomes that way since we're using a real text box instead of a regular text box or a rich text area or something similar to that. Then once we go through all this, we pull all the text out, all the values out, and put them in this temp list. We are returning the temp list. And back up to here. Wherever here was. Damn, where were you? Where were you? Here. Yeah. Next, we then check the field list that we got. We go through there. So now, if we are not updating, then we don't want to use the ID because we're inserting a new record, and therefore we don't want to use the ID field. We want to just have the auto incremented up by 1 by SQLite's normal stuff. Then we get the, and this is where the error was coming in. Then we get the field info dot object update dot get type dot field list 1. So basically just getting all the field info for the particular field that we're looking at. In this case, it would be the next one would be the name. That'd be the first one that would be that would fall into here. Would be the name field. Next, if the field info is not null, so we're not trying to process a null field for whatever reason, then we want to convert the field into the appropriate type. Since the data in the form is all strings, we have to go through with this and say, okay, take this data and turn it into whatever the field type is expecting it to be. So this is some more of the black magic of C# here. We can use this to say, okay, I have this random bullcrap value here that I have for some random bullcrap place. That's not the type that I know we need to have it for to fit into this object that we're trying to fill data for. So what I want to do is I want to look at that object and say, okay, this field has to be this type. Here's my bullcrap data, turn it to that type. That's what this does. However, it'll throw a null, well, it'll throw an exception if you don't catch it. It'll throw an exception if you're not, if you pass in something that can't parse to the type that it wants to parse it to. In our case, when we tried to pass in an A instead of an integer, it ended up causing an exception here because an A cannot be parsed into an int. So this is one place where a little bit more stuff has to be built in to handle that. So assuming that it can be parsed into the proper value type, does so, stores it in var value. Again, var is the same as object. You can use it. It's similar to, actually it's the same as the var in JavaScript. It just stands for whatever the runtime and compiler has to figure out what the hell it's supposed to be at the time of when it's being set. So it's similar to auto in C++ as well. So we have this val, we're saving the value there. The compiler gets told what to do by what the type is, or what the best guess of the type is. So it is possible that it could look at this and say that it's a decimal instead of a float if that's what you're looking to change it to, or something like that. Unlikely because of how this works, but it's possible in some case somehow that it could happen. And then we're using the set value of field info to then set the value for that object. So again, field info is the info for the field that you are passing here. So field info isn't like some non-specific thing. It's the field info for the field that you passed into here. So this field info on the first time it would fall into here would be for name. So this is the field info for the name field of the A-plating object. So you can consider this to be aplating.setValue or a name, or maybe aplt underscore name.setValue aplt, then the value to set it to. That's how you could read that as, instead of field info, if that makes a little more sense. Now, if we are updating, we do want the ID, and so we just cut out this one if condition, and we just process everything. So we get the proper SQL string to update the record that we're trying to update. And then we return the object to update up to here, which we then cast into an A-plating object, which is stored as object, so we don't have to do a whole bunch of different stuff up here to store it in. And then we return that to wherever the hell that got called from, up here, which is object to update, which again is another blank object. Again, we're doing it this way because this way we don't have to handle each individual object. We can just pass through this random ambiguous object to this and let the code parse it out the way that we want it to. So that way we don't have to handle a whole bunch of extra code up here. And we don't have to handle a whole bunch more code down here. So it causes things to take up less code to do it this way. Though it may not be the best way to do it in my opinion. But anyway, so we do that. Again, if we're updating, then we just pass it through as true. Now once that's done, we call create new record. In this case, since we're going through assuming that we're creating a record, call create new record, which should be down here somewhere, or maybe not. Create new record, here we go. So create new record is going to build the SQL string and then execute the SQL command. So we pass through that object new record object. We build the string and we call build insert SQL string, pass through that object as well. So we come over to here. First thing we do is we do the insert into space plus the table selected plus a parenthesis to fill out the field list to the list of fields to update on that table. And here again we are building up our list of fields. Again, we're skipping the ID field in this case since we're creating a new one. We don't need it. We actually don't even need it in the next one either, in the update, because we're not setting the ID field to anything. But we still need to handle the ID value in the update, so that's why we have to handle it with a false or a true boolean in a bunch of different places. So at first what I was doing here is I was getting the field list from the object, forgetting the fact that this object is based off of a struct where the ID is not name specific or name is not case exact. You could say to what's in the database. So I was running into issues trying to figure out why things weren't updating the first time, and then it's like, oh, that's why, because we have these fields that are not named properly. That's what they're supposed to be. So that's why this is commented out. And instead I'm using the column list 3 list that has the columns for the selected table for the DB editor instead. And so we're just going through that, and we're building out the field list for the update, appending commas to it and all that. Then we have to strip it off the end. Then we do the close parenthesis, values, open parenthesis. Then we have to build the values list. And then this, again, is kind of where we get some interesting stuff happening. So we're using the object again because I want to do something specific with this. So we have the val list, which is itself an object, obviously. So you see the pattern going on here is we're using a whole bunch of ambiguous code to do this. val list is a list of objects which we get from the get list data object, which is over in here. It's basically the same thing as get val, except we are doing something different. So we are returning a object temp list. We're passing in the field list, the reflection field info list, the object, and then a boolean. Add dot get value str object. Well, for one, we're not turning it to strings like we are up here, and we also have this condition to check for the ID. So we probably could do them all this together in one thing, but that could be later for the refactoring. So we can do that, processes all that, and we get back the list of values from the new record object. So this is the values that's stored in here, which is the in this case ape lighting record that we updated previously, earlier in the code. We're looping through that now down here, and we are checking to see what the types are of the different elements of that list, because we have to have different types of notations for different types of things. Like, for example, strings have to be surrounded by single quotation marks, single quotes, in order to be properly formatted. So we have to check if the object is a string. If it is, then we are wrapping it in single quotes, and then we are moving on to the next object. And if it's not a string, it doesn't have to have those in it, so we just put it in like this. So that covers all the other stuff, the ints, floats, and doubles. Probably have to also add in some sort of longer uint64 or something here to handle populations and things like that for modifying of the save files. And so we do that. Then we lop off the trailing comma again, and then we close the values list with this here. Then we go back to the previous function, the create new record function. So then we set the dbcon. Then we create the SQLite command to execute later on. Instacom insert command, pass through the SQLstr and the SQL string and the DB connection. Then we do a try, open the database, and then execute the query. We'll execute the non-query, we're executing the insert statement. And then we're updating the database editor data grid view at the bottom. So all this code used to be in this function here, this cbox table list dbe selected and exchange. So this is the code that would change what was showing up in the database editor data grid view at the bottom of the form whenever we changed the table. So since we need to do that again to update what's been changed or added, I decided to take that code out and put it into its own function and just call that function from there instead, so I can call it from other places too. So we just call this, it reloads all through this code to re-grab the data and update the data grid view. And that's how the code is working now to make that happen. So it was, I did all this just today, but it was, like, I don't know, it's stuff that I thought, it'll never work. It worked, and is, just a whole bunch of things lined up together to work properly to allow me to do this pretty quickly. But I hate using ambiguous coding like this, because this is like something you would never do in C++, and I don't even know if you can do it in C++. If you can, I would never do it. But it lends itself to this because it makes it so I could do this with lots less code and lots less complexity. It's actually, they're using the object class for some of this stuff here too, for like the event listening for the eventing system. So not how I'd really like to do it, but that's how I'm doing it. But yeah, so we got that going now. So now it's just a matter of filling out all this stuff where we have like these things to include all the other stuff. So not quite done yet, and we do have a lot of code still to do, but at the same time, now that it's working for one table, it'll be easier to do it for all the other tables. And then we have to work on the edge cases, handling all the weird tables that don't follow the main structure of what most of the other tables have. Like the ID name, description, some of them go just, whatever. IDs, like the cross-reference tables are IDs only. You have the settings table, which has the description as a third field in the table. Well, fourth field in the table. And so those kinds of edge cases will have to be handled on a situational basis in the code. But yeah, so we're getting closer, much closer. As a matter of fact, I would say that we're getting really close to finishing this tool, which is interesting because I didn't think I'd be finished this soon. Okay, let me rephrase that. Qualified. Close to finishing the database editor. We still have to do the future casting stuff, which is going to be a really interesting nightmare to figure it out. Maybe not. Maybe it'll be easy like this stuff was. Who knows? Alright, well, thanks for taking the time to watch this double length. I said maybe 10 minutes, it turned out to be 40, but whatever. Thanks for taking the time to watch the video. This stuff is pretty cool in my opinion anyway, to actually have it working. Sometimes you have an idea and you're like, okay, how can we make this work? And then once you get it working, it's like a hell yeah kind of moment. It's kind of what this moment is for me, because now it's gonna be just, everything's been figured out. It's just handling all the BS, extra BS that we have to cover for it to work for everything. This will work, the way it's done now will work for 80% of the tables that we have, so yeah. The save database, the save file editing's a bit different though. That's to be expected because it's not exactly the same kind of stuff as this. But this is good because this is the main thing that the tool should be able to allow you to do, which is to modify the database from within the tool without having to have much SQL knowledge and without having to have an SQL editor. So this replaces both of those things, so that pretty much anyone could come in here and start creating data for it. Start creating a mod, adding more stuff in for a mod. Without much knowledge in how to do SQL and stuff like that. That's mainly what this tool is being created for and aimed for, is people that want to create mods. It's like RPG Maker, for example. Those different programs are created for people that want to create RPGs that don't necessarily know how to code, or in some cases aren't able to learn how to code because of whatever reason. So that's kind of what this tool is aimed at, those same kind of people that don't want to take the time or don't see a reason to learn like how to do SQL commands and and searching queries and things like that, just to make it really simple. But if you haven't done so already, I would appreciate it if you'd subscribe to the channel, so you stay up to date on what's going on with the game and other things like this. And I will see you next time. Alright, hey everyone, this is George Williams from Lifetime Productions Squared, and we're here to do the last bit of our developers vlog. I'm not sure if I'll do this first, put this as like the beginning of it, or put it at the end. I'll probably put it at the end, because it's kind of like at the end. But so what I'm doing is we are going to be talking about a couple things in terms of the coding and different things I've been working on. I'm not going to be having anything on the audio or the UI in this particular video. They'll have their own videos that'll be not part of the developer's log per se, but they'll be kind of like just like stuff I'll put in the ModDB update. But they're really out. I'm pretty sure I'm not going to get around to actually doing the UI stuff because this thing that we're going to be talking about has been a lot more difficult than I thought it was going to be. Maybe even won't have the audio ready. I'm actually like right on the wire as far as like it's literally like the day before the release. I'm probably release later in the evening tomorrow, but I still haven't finished the audio track I was working on. I got a lot further. I guess I'll let you hear what I have so far, but I don't have it complete to the point to where it's like one single piece of music yet. Even if it's just a couple instruments, it's still It's kind of there for some instruments, but there's some spaces where there's supposed to be stuff in between two different phrases from different instruments that don't have any connecting stuff in between them. So it's kind of like a dead air space in there. But we'll talk about that later. So what this is, this just insane thing I decided I wanted to do right at the spur of the moment a couple weeks ago. I was like, you know what? I want to make an proof of concept economic system so that I can figure out what needs to be done, how it needs to be processed. I kind of talked about this during the live stream I did, developer vlog live stream I did little while back on YouTube. If you haven't seen it yet, it's on our main channel. It's on the Left Man Productions channel, but you can go find it. It's one of the live events, so it's easy to find. But I was talking about this, and it's it turned out to be a lot more complicated than I thought it was going to be, even though I thought it was going to be complicated as hell. So let's talk about why it's what it is and why it's so complicated. So, as you probably know, I've known from other videos and stuff I've done, I like to do a lot of proof of concept stuff before I put it into the main code, because I want to see if I can make it work on its own, what needs to be done, and what might be needing what might need to be added to the main code to make it work. I don't like to go in there screwing around with the main code, adding huge things in, unless I kind of have an idea of what I need to do and what needs to be, how it's going to be integrated. Because if you do that, that's when you start getting all kinds of weird crap that happens, like strange bugs and things like that you don't really necessarily anticipate. It's not going to anticipate everything, but when you actually build a proof of concept model of the thing you want to add in, you get an idea of you get a feel for the complexity of it, what you need to do to properly implement it, and you might have some kind of pre-realizations about things that might go wrong when you plug it into the code that you already have. At least that's what I found through all of my coding so far. So I decided, you know what, let's go ahead and do this. Let's make a proof of concept economic thing where we'll have some just generated test systems, and it'll have be connected in this awesome way, and they'll trade over these trade lanes, and we'll create this thing where it'll create demand and supply, and they'll trade with Zarn, and we'll use all the resources, and it'll be awesome. So I started coding, and I started coding some more, and coding some more. And then I realized, okay, this is going to be a little more complicated than I thought. So let's first talk about the whole precept of an economic system. And yes, this is a new and better version of the old one of these. Let me open up the old one. Because here's why I wanted to do this for. If you look at the old one, it's okay. This old one, it just shows you a basic layout of how maybe something will be set up. You got your systems, you got your connections. Now, the main problem with this is this does not have all the complexity that's needed to kind of properly think about how this would actually work. And this is kind of like the simplicities, the economic system for dummies kind of thing. I don't know. You got a bunch of systems. They all have maybe at most 2 or 3 connections, but they're pretty much, it's not very complex. And you also don't have any different types of gates. So these are all active gates. There's no inactive gates and no one-way gates. So I was thinking about this. I was trying to use this to create sort of to go through and kind of walk through how this would work and create. Another thing I like to do is I like to walk through things and type down all those different steps that have to be done, so that I can go back there and say, okay, we need to consider this stuff in the code. We need to do this with this code. This code has to do that, and you can kind of almost pseudocoding it, but not really. It's more of a it's not, well, it's kind of but it isn't actually even a design document or a requirements document. It's more of here is what I want the code to do in actual, words of what it should be doing. And then I can take that and look at that and say, okay, so I want to do this, so the code has to be able to do this. Check this particular variable or this map for some value to see if it's there or not. And it can fulfill this condition I have set up in the way I want it to work. And so I was looking at this and thinking, okay, so the code I've created now creates something like this, but we have two other gate types in this, and it's a lot more complex than this. And I started trying to do it with this and realized that it just wasn't going to work. This is not complicated enough.